In this specific lesson, we are going to learn how to use machine learning, and we are going to perform a practical example for that also. Before we start with the actual code, we will do some introduction. What exactly machine learning is? Machine learning is a subset of AI, and AI stands for artificial intelligence. So, there are quite a few uh, artificial intelligent machines are out there, but all of them are not machine learning based AI. So, when we talk about machine learning AI, that actually uses data to make predictions, and there are two kinds of methods by which it makes prediction. One is supervised, where the algorithm runs from the existing data, and other one is unsupervised, where there is no data available, but whatever data is presented to your machine learning algorithm, it will automatically uh, make decisions based off of that. Then why basically we use Python for machine learning? So Python has quite a few advantages over other languages. So because Python is a modern language, and it has rich libraries and frameworks which can be used, and again, there is learning Python is as easy as if you put your 2 to 3 weeks properly, you can learn the language, basics of the language. There's a huge community and support, so if you type any specific thing, any specific problem on the Google will actually provide you lots of code available, and we are going to see an example of that. So now I'm on Google and I'm going to type for a specific thing. For example, anomaly detection using Python code example. So as soon as I type anything, you can see there are over 3 million records which are providing me this specific code. So there is a huge resources available there. And then you have flexibility and integration. You can integrate Python with quite a few other languages. The data handling capabilities of Python is enormous. You can load huge amount of data with ease. Then Python can be used for a basic website, but you can also use it for a very advanced computer vision apps. So versatility of Python is too much. At the same time, academic and research friendliness. So there are, if you can see, I think it is one of the most popular language which is being used by the researchers at this day and age. The industry is also providing you quite a good support, and they are adopting it, and they are also using that thing for their own purposes. So for example, if you go with Google, so Google have provided a Colab environment where you can do your own Python thing, and you can see that they are providing a virtual machines which have RAMs and disk available for the enthusiasts who are working with Python. So having said that, if I look at the learning type of Python, so that is as discussed based of two major things, that is supervised learning, another one is unsupervised learning. There is also semi-supervised where it will work on hybrid form, and there is also another thing called that is reinforcement learning. So I have actually mentioned all of these over here, so you can go look at the different things, and if you wanted to go and work more on the machine learning things, so you have a place available where you can go refer that. If I'm using the linear regression, so is it regression and it is using to predict the values, and it is a supervised kind of learning. Or if I'm using k-means, so it is a clustering type of thing which is used for grouping similar data points, and it is unsupervised learning model. So this actually chart will help you understand that whatever method you're using falls in which specific category. Again, you can also categorize machine learning models based off of the problem type which is they are solving. So, for example, for predicting category, if you know that there is a email spamming algorithm at the back end, which is AI based, which push the emails which are spam to your junk folder. So, this is one of the things which you do using classification model. Regression model is normally used for predicting continuous values. So, for example, house prices over the years or USD prices over the years. Then clustering model which will actually group things together. So, customer segmentation. So, for example, high profile customers, medium and low profile. You can do that. Then dimensionality reduction is another thing where we use for simplification and visualization of the data. Again, when to use which model. So regression, as we have discussed, that if you wanted to predict numerical value, we can use regression. Classification is being used for categorizing data on a predefined classes. Then you can use clustering, dimension reduction, and reinforcement learning. All of these guys are available with kind of usage that when to use what. And like whenever you go for selecting the right model, there are quite a few things which you need to look at, which includes the what kind of data you are dealing with, what kind of problem complexity you are dealing with, and interpretability is the another thing. Like if you are working with decision trees or something else, that also decide that which model to use. Now we are going to go to the recommendation system. So for downloading the dataset, we have this groupplans.org datasets, and I'm going to open this specific link, and you can see that there are different multiple items available over here. What I'm going to do is, because I'm just learning this thing, so I can download the smaller file, that is ML latest small, and I can just open this specific file. You can see that we have movies available within this zip file. What we can do is we can move the movies.csv file on our Google Drive. If I go to drive.google.com, and if I you can see that I have a folder available for my notebooks, and in collab notebooks I have created a movie recommendation system, and I'm going to just paste the CSV file over here with the movie, so I can just drag the file from here and push it over here. So this is how you're going to add the data. A live example for the code, and for that I'm going to go to Colab. So number one, the first block of code is here, and we have just imported both pandas and numpy, and we have given aliases to both of those guys. Then we have connected our Google Drive, and our Google Drive we have a movies.csv. So I'm gonna go to my Google Drive and see that in the movie recommendation folder, I have a file with the name of movies. And specific is this specific statement what I'm giving it, that it has a separator which is comma, and the coding is Latin 1, and the columns which we have in this specific CSV file are movie ID, title, and genres. So as the name suggests, that movie recommendation system is built to recommend movies based off of the selection of the user. Then we are going to process the genres, and for processing the genres, what we did is, like, we have created a movies array in this specific thing. What we are going to do is we have split it using vertical bar. So it will actually, because there is a column which contains genres, and genres are basically separated by vertical bar. So I'm going to show you that how it looks like. So let me move to the CSV file, and I'm going to movie recommendation systems, collab notebooks, movie recommendation. Again, I go to movies. You can see that we have movie ID, title, and there is genres available over here, and you can see genres are separated by vertical bar or pipe. Having said that, first we have splitted the movie genres with which which are like separated by pipes. Then we have removed uh, whenever we have NA or null values, we are exchanging that value with a null string, and we have provided that this is a string type. So till here everything looks smooth and we have covered over here. After that, actual fun part comes in, and for that basically we are using sklearn library for the specific thing. sklearn is a scikit-learn library, and we are using scikit-learn, and we are using a specific thing which is called feature extraction, and we are using the feature extraction from text, and we have imported a specific vectorizer for that specific reason. So using this TF-ID, TF-IDF vectorizer, we need to provide some parameters. So number one is word. So in the specific text, we are going to analyze the word. And the range of the word, like that word may be of one word or two words. So we have provided range of the words which we are going to analyze. The min-def is basically we use a min-def parameter, like it stands for minimum document frequency. So it's asking that how many times if it appears it should take that thing into account. So if we provide 0, that means that it will ignore the minimum document frequency and take any word which occurred any number of times. It's okay. Then stop words equals to English. So we are using English language, and the stop words are, if you're aware, is, the, and all of these guys are stop words. So if I go to Google and I type that English stop words, so it will show me that the, is, are, all of these guys are stop words. So we are asking it to ignore the stop words. Then we have created, once we are done with this, we are going to performing the fed tf.fed. That is TF-IDF vectorizer.fed transform. It will actually executing and creating the matrix which we wanted to use. So we have created a TF-IDF matrix over here. So let's review the matrix which is created. So I'm going to add a code over here, and I'm typing TF-IDF underscore matrix. And when, as soon as I click on play, it will show me the dimension of the matrix. So we have 9742 by 177 matrix available, which I can use. There are total 36628 values which are available. And if I click on dot over here, you can see all the matrix related functions are available over here, and I can use any of these functions to perform any of the matrix related operations. So again, we are using scikit-learn, and we are using the matrix class, and in the matrix class we are using that is pairwise and import linear kernel. And now I'm going to perform a cosine similarity of my TF-IDF matrix. So what I did is linear curl TF-IDF matrix comma TF-IDF matrix, and I'm going to generating a similarity cosine for this specific matrix. So basically, whatever function you perform using statistics, it actually perform on the numeric values only. So what exactly we did is we have converted the words into numbers, and from the numbers we have created a matrix, and now we are actually checking the weight for that specific number, so that which thing is relating to what. So that's why we are doing the cosine similarity over here. So to understand this further, linear kernel is comparing every genres, like every movie's genres with the other movie genres. So we have provided in both the parameters, we have provided the same matrix. So it will compare first matrix every movie with other matrix every movie genre, and like based off of that it will create a similarity cosine. So let me print that thing over here. So I'm going to print this thing over here. I just click on print and cosine similarity, so it has printed the matrix, and the size of this matrix is total 9000 plus rows which we have available. So it has a 9000 plus rows and 9000 plus columns, which is like containing a float value. So if the value is near to 1, that means that their genres are matching. If it is 1, it is 100% matching. If it is 0, it's not matching at all. And if it is in between, it will showing, like for example, for this specific matrix area, it is 0.06, means it's a 6% match, and it's a 31% match, and it's a 100% match. So this is what actually it is doing. After that, we are creating this is for the title, so it is connecting an index column with the title and creating this indices data frame, and we are going to use this indices data frame in our next function. So it has created this, and like out of this indices we are getting the indexes from this specific indices item, and then based off of similarity score, what we are doing is we are actually getting the highest the movies which has highest number of similarity for this title which is being passed to us. So for example, so if I repeat, the indices of title is creating identification index for each title, so the movies can be recognized. Then we have created a similarity score, which is a type of list. And what we did is we have pulled all the, you can see cosine sim has this specific matrix which is related to that each movie is how each movie is similar to other movie. So that's in this matrix. So we have stored those specific enumerations in this similarity scores, and then we are going to sort similarity scores. So you can see that we have sorted it over here, sim score, and reverse to means that we are going to sort this thing in descending order. So the highest similarity, that is 1, will appear first. Then what we did is we have created the sim score from 1 to 21, because you know that we have already sorted it in descending order. So we are pulling top 20 movies out of the 9,000 movies. So all 9,000 movies, it's going for every movie and just pulling the top 20 movies which has the similarity score near to 1 or near to 100%. And then we are going to load that thing in movie indices. And once it is loaded, what we are going to do is we are returning that specific movie indices. So the function is genre recommendations. So now we are going to call genre recommendations over here, and we have written a movie name. It can be a variable movie name. So I'm going, if I am going to play this thing, you can see it has provided me Toy Story 1995 is similar to Ants, and it's similar to Toy Story 2, and it's similar to Monsters Inc. So what I'm gonna do is I'm going to select this Monsters.Inc, and I'm going to see that what kind of similar movie it will pull. So right now you can see that we have Shrek, we have Table this thing, and we have Turbo 2013. So now I'm going to pull similar movies to Monster, and I'm going to play this thing. So you can see that similar movies are appearing over here because both of those guys have similar taglines over here, so that's why it's appearing over here. And we can similarly pull different items from here. So if let me open the CSV file, you can see that we have a movie with the name of Jumanji 1995. So I'm going to change this specific thing to Jumanji 1995, and I'm going to play. If his spelling is correct, it will show me the movies. So you can see that it has pulled the similar movies and recommended similar movies over here. So this is in this section we actually learned types of machine learning algos, and we have learned why we use Python for this thing, and we have learned the entire code of movie recommendation system, and how we have used different statistical functions, how we have converted the text into the numbers, and how we have used different statistical function and metrics to actually pull the recommended movies. Thank you so much.